We've been working on the skylight design, um, and we've gotten to a point where we're ready to start drawing the shop drawings. By we, Super Sky and our engineer, working on the skylight portion of the sunshade skylight assembly. And as I was working on the design, I realized it wouldn't be hard to make a little video explaining what we're doing with the design and why and how it works, because I think there's a lot of other people involved who could use that information before the shop drawings are done. So if you can bear with me for 10 or 15 minutes, I'm going to walk you through the design where we have it right now. I think it's a good design. We know that it works structurally, and this is how we're going to proceed for our submittal. This is informational. I'm not submitting it for approval or comments. I just want to let you know what we're doing, and I think you'll agree with most of what we've done here. So let me get started. Here's our skylight, and if you can sort of see my mouse darting across the screen. The skylight consists of a lot of 4 glass light modules that are all 11 foot by 11 foot. And so the frame is going to be designed to kind of build those modules. And we've got a design where we can sub-assemble it in different ways. Some of them will be built as 4 lights. Other ones will be built with a rafter and maybe a rafter, and then piecing some parts in as you would go. And I can illustrate that as we go. This approach keeps all of the thermal expansion within each 11-foot module, so there's no accumulation of thermal either on this 100-foot run or this 100-foot run, and it takes the reactions out at each of the 110 posts. So with that basic description, let's look at the system. So what I have is a model of that module, and you can see we've got the double rafters here. We've worked to skinny the column up as much as we could, and probably the most important first thing we decided was we're going to fabricate this steel post and plate as part of the skylight. So it's going to pre-assemble tight to the frame, which will allow the skylight frame to square that up. So because we can cut the aluminum so close, and then we've got these 2 rafters holding the post, we can get a very good location with minimal tolerance, so that after the skylight is fit, the sunshade can bolt right on. We don't have to worry about tolerance from this plate going up. This should be good within, very tight tolerances. Let's go over this assembly right here. I kind of took a minute and adjusted it. And you can see that the end of the rafter has a pocket machined out of it. And that's going to allow us to make a splice joint. And I will show that to you later on. But this is a CNC cut with an end mill. And then we'll make a matching cutout on the other bar, so that we can get a good seal between the 2 bars as they expand and contract relative to each other. Within that, there's some splice plates that will hold it together. And I'll show you the other end where there's a slot to allow that movement. And below that is an angle that's going to be bolted to the steel and bolted to the fixed end of the bar. That will hold this together. So you'd have one rafter and another one on the other side bolted to the steel, and the 3 bolts and the 3 that should keep it the relative positioning right where we want it to be. We were very concerned with the different cambers and twists and deflections in the beam affecting the orientation of the posts. We didn't want them to be leaning at different angles, or in other words, there was a lot of concern of tolerance and how this post was set how that would affect the bolting up of the sunshade. So we've given this quite a bit of thought, and we're confident that this will work, where we can bolt this together and we'll let the skylight frame hold the post plumb and level. There still need to be some adjusting, but the bulk of the work will be done that way. So this will be set. Then this channel clip with this plate on the bottom is screwed or tapped into the gusset plate to hold it there after the next rafter is slid up. And it's hard to tell, but these crossbars have cutouts on the bottom, and this plate is welded to the clip, so that when they go together you just see a finished surface. But it allows us to drop the bar in after the splice joint is made. So we're going to want this rafter to be here and bring the next pair up, and then do this splice joint, then attach the channel clip, then drop in the crossbar. We made this crossbar, the one that's uphill, in the middle of the bar. It's not as complicated, but we're also going to make that be a drop-in as well, just to aid the installation. So we have a lot of options for how to sequence putting the sticks together. This is the other end of the notch, and you can see we'll machine slots here and a matching pocket on this side. It's got a funny miter that no one will ever see. That helps us with the screw placement on the other end. We want the channel clip to be fixed to the fixed end of the bar. This way the moving bar and the light of glass that sits on this crossbar, they all slide up together or contract away together. So that's a system we've used many times, especially on big skylights, where you don't want all the cumulative thermal to impact what you're doing. As we've worked through the design, we asked the question about the different glazing systems, and it became even more obvious to us that option A was the better way to go, because if we would let it just all expand, each of these posts would have to have covers that would have expansion in them. But by fixing the end of the skylight to the post, our closures on here don't have movement to worry about. There is one rafter sliding, but there's a good way to do that, and we don't have to worry about it. The rafter will slide underneath our closure, so we're good there, and this has worked out to be a very good way to make this particular skylight. If we look at the crossbars, you can see they are cut with CNC cut notches as well. So we're creating a little drip edge here so we can hook it over the edge of the rafter and force the water to drip off. There's also a feature on the wall here where we relieved it back a little bit, and that helps with the water and surface tension. We want it to come out of the crossbar and then attach itself to this wall so that it drains with the rafter. That's something we've also done many times in the past, that little relief to let the water catch. The drip edge helps. And we have these, every other rafter is what we would call an infill bar. It's a lighter tube because it's only spanning the 5 feet. And that bar also has a drip edge cut in it, and it's going to drain into the crossbar in a similar way that the crossbar does to the rafter. And see, they all have these, just a little notch to help with the heights, and then we've got a good drop off so the water can pass out to the next level. We typically call this a 3-tiered system because you've got this bar draining to this one, and these drain either way to the rafters, which then carry it to the curbs where they're weeped out. So that will explain our system drainage anyway. So moving to how we're going to subassemble the frame and erect it. Some of the frames will go together with a 4-post construction, and these will be lifted with a crane and set down. They could probably also be stick built depending where the platform is, with the crane just bringing the parts to the guys. But the first frames will have to be, a table with 4 legs so they stand up nicely. After that, we can bring in these assemblies and add them on. So these little bars here would be actually the end of that. And then you could build that one and then add another one on this side. And I don't know if I can pick this up and move it. So that should go, and it would go in here, and then another one would go there. And that starts to leave a lot of options for how we want to build this. At that point, I'm going to get rid of those parts because I don't need them anymore. And we're going to look a little closer at this. The frames will be built in larger sections, if not the entire frame. And then they can start to square it for good alignment and getting everything in square. And once it's squared, they can clamp it off, probably with some kind of improvised block to hold it in place or a strap, and then we'll have to level it for height. With the cambers and deflections in the structure, we need a lot of vertical adjustment. To that end, we're putting a bolt down here to just kind of hold the height until we do the connection. When everything is ready, we're going to have a welder come, and it's a lot of field welding. But I don't know that there's another way that will get us the tolerance we need. And each of these posts, after it's leveled, will get welded with 4 plates in the bottom down to the W36, was it? By 395, the great big beams. And then we'll be fixed there, and the skylight frame will have held these in the right alignment. So we went over how the finished joints are machined. Try this. And you can see here's the rubber splice cover that will fill that pocket so that water transfers without going through the gap. And that's all set in sealant, and the Dow 123 tape will stretch as much as we need it to for this. And then every 11 feet there will be a joint. We think that will work very well for this. Okay, I'm not sure what happened, but all of a sudden my display got kind of weird. So brought the file back up, have it recovered, and it's still struggling. Probably the next question is, how are we going to seal around these posts? Which is a very valid question. And let's turn on some flashing. So we got a flashing piece we're going to put in, and that's going to be between the bars, and it will drain either way. And then we can insulate that later, but we also will have some covers, collars I call them, that we can put around there. So we'll have an upper and a lower, assuming I can work the computer. And they'll bracket that, and then we'll take some more Dow 123 and wrap this upper edge so that it can seal to the steel. And then they'll overlap this inner flashing piece so that it will drain. We will shingle it so that water will just shed as needed, and that should work out pretty good. After that, we're going to lay some insulation on top of it, and we will have some panels that glaze to the glass just like the glass will. They're going to attach to these vinyl fillers to keep a good thermal break, and they're keyed to the rafter so they're allowed to slide. They're not fixed tight, so when we have the rafter sliding, the panel can stay put while the rafter slides as needed. And then we're going to have to cover this somehow. So we've got a cover piece that we're going to make in 2 halves. I know I put this exterior plate, but I didn't have anywhere else to put some screws to clamp it together. And then we'll have a caulk joint here, and it will caulk to the glass. So if I turn the glass on real quick, you'll start to get an idea how our barrier system is going to work. And I probably should have started with barrier system. Skylights are not designed as a pressure equalized rain screen. That's a curtain wall deal, and that works very well for them. But we're horizontal, and we're much more worried about water getting in due to gravity pulling water through. Because once it comes in, it can come in a lot faster than we can take it out at any kind of slope until you get to like 15, 20 degree slopes. So everything SuperSky does is based on a barrier made at the top surface of the glass. So if you look, our details all the sealing will be done at the top surface of the glass. And then there's a backup drainage system. So the system that I was showing you earlier is not intended to be pressure equalized. It's not our main line of defense. It's the backup. It's a very good backup. But the main thing we do is we build excellent barrier systems. So that's where this closure goes in here, and then we're going to wet seal it right through there, married into this sealant joint, and we've got a similar one on the top. And that's going to be our cover. And we've made these sort of like a inverted U's so we can fasten an upper cover to it without penetrating the system. It's another reason that these screws are on the outside. They're not really sealed for the building. We're going to bed this and seal it and then compress it together, and then that should be a very good barrier at every one of those post conditions. So if we go back out, you'll start to see we've got glass and panel, and everything has the same weather seal joints that we've tested more times than you can count. Every skylight we do, that's the barrier system. I know in earlier discussions there was concern that we were splitting the skylight into too many parts. But as you can see, it's all designed to be a system that works together using the same barrier seals that are in the glass. It's not going to move at this joint going this way. It always has had to have the movement it has. But this double bar doesn't increase any real chance of problems. It's actually given us a good spot to seal this post very well, I think. So that has sort of gone from some of the detailing to the barrier system. So let me stop again and I'll come back. Okay, I'm going to turn these back off because there's other things that I need to show you, and everything happens in this area, so it gets a little crowded. So we have the post up, but now you got this big welded steel post sticking up where everybody can see it. And we've decided we're going to cover that. If I can, we're going to have some little clips put in here because we can just attach it to the post. That works pretty well. And then we're going to put some covers. Now let me move this one out of our way, and you can see how we're going to do this. We're going to have a clip there that's going to hold this center section, and the center section is going to go up between the bars. Now if I had the flashing layer on, which I can turn on, you can sort of see. Actually, if I change that color, you'd really be able to see it, because that piece, I believe, is white. So that is going to plug all of that up. And then we're going to hide these clips, and it will look very pretty. Let me go back a bit. And then we will need tolerance because we anticipate up to 2 inches of adjustment at the bottom. So we've got an inner base cover that would just wrap around there and set in sealant as well. I've got a couple of screws. I'm just going to have them work them in through these holes. The holes will be visible, but I think that's probably better than screw heads. I could also do it with just a sheet metal screw through there. These joints would just be hairline joints. We're going to squeeze the metal tight. We're not going to caulk it. We're just going to leave it be an enclosure. And when we come back out, so now we've got inner closures everywhere, and we've kept it lined up with the rafters to hide the support clips that hold the rafters. I do need these visible screws, but they're all painted to match the frame, and I've tried to keep it as tidy as I can and still allow all the movements and strength that it needs to have just to hold itself up. So, see if there's anything I'm forgetting. White flashing, collars, glass. There's slip pads on the supports too. I didn't get to that. I think that's where we're at. Now, we're hoping that these base plates can be made smaller. That's something that's still up in the air, but I've got a concept for how to seal it, and that part is good. This will adjust with that. And everything else I think is working out pretty well. So if I try to go underneath here, I can even try to give a little bit more of a perspective to kind of match that one that's on one of the architectural drawings. So that's where we're at. We've got the crossbar spanning, they're every 5'6", is it? And then we've got our posts. Tried to clean them up, and I think we're doing okay. I think I've got a method that'll work for installation, for assembly, for fabrication, for drainage. Structurally it works. It keeps it square. It's really good to hold everything in proper alignment so that the sunshade can ship from England and bolt right on. I think we'll have to take some steps to make sure our bolt patterns match perfect, but that should be okay. And I think we're off to a really good start with this. An awkward start, but I'm catching up, and our design is looking okay. So I appreciate everyone's patience, and I hope this starts to answer some of those questions I know you've had as well as I have. It's just taken a while to get to this point where I could sit down and start answering some of that. So the shop drawings will be coming soon. They'll be based on this. I'll be using this to make isometrics in the shops, and we can look at it in more detail. It should be good. I'm hoping it's easy to approve. I've given it as much thought as possible, and we've talked about it internally to make sure it's as high a quality as can be done. So it looks to me like a good skylight, and I'm pretty happy with it. Thank you very much.